Good evening, everyone. My name is Maxim Vuets, and tonight I would like to tell you a little story. I am a music lover, and I have a ton of music, and some of them is better than others. So I'm usually not a big fan of playlists, but I have just a single playlist of like the best music track that I like, that I can always listen to. And what happened was that I ended up having like multiple playlists that were overlapping, in other words, having duplicates. And one Saturday morning I decided to write a quick and dirty Perl script to merge them together. And then I thought maybe somebody else would be interested in kind of like seeing what I did. Maybe they would learn something new. So I sent an email to the AmsterdamX.pm group asking like maybe somebody would be interested in a 10-minute talk about this very simple script. And Upasana and Steven replied like, maybe you can extend it to a 20-minute talk. So I had to work out a way how to fill out all the time slots. So blame them. This is also the very first time I am delivering a proper talk. Before I only did very simple lightning talks. And I screwed it already because I am horrible time management. So I had to finish my slides like during working day. Don't tell my team. So please bear with me if something doesn't go smooth. I will begin my story with how I ended up having like all this nonsense in my playlist. This is a Russian Facebook clone. It even looks familiar to old, many years ago Facebook, if you can recognize. It's very popular in post-Soviet countries. And this was a website where I think I started listening to music. So people could upload their tracks, you can make playlists and start listening to them. And you also have this hair-shaped icon, so like a thumbs up on the Facebook that you can favorite. And that was pretty much a way how I favorite my music tracks and keep track of what I like. But then, does anyone recognize this website? It's Grooveshark. It ceased to exist a few months ago due to some legal regulations. There was another source of music. It's kind of like a music cloud where everyone could upload their tracks and listen and even download them. And then the system would try to work out a way how to group them into albums, because people occasionally upload full albums, but rather occasionally just random tracks. And they also had a feature to build up playlist lists, etc. Another very popular, probably the most ancient music website, Last.fm, doesn't store music per se, but allows you to so-called scrobble. So keep track of music you listen to, upload it to the website, build charts, recommendations, share with friends, etc. And this was yet another source of music. You can see this is a list of, how they call it, love tracks. Besides an actual playlist, you could also just add a track to favorite list. This is what I did. I didn't make sophisticated lists. And there were a couple of many other websites that I used to listen to music. Some were shut down, some I didn't like anymore, so I had to transition. And eventually I ended up in a situation when I had this playlist scattered across the internet and decided to kind of get them together. So there was a history. No, sorry. Now, Last.fm is actually not that bad. They have a functionality to export a playlist in a structured format, in a TSV file. All other websites doesn't give us that opportunity. And what I had to do actually, brute force it, copy-paste just HTML page into some kind of text file to save a playlist from a site. Some sites that wouldn't allow me to do that easily. For example, they would as you scroll, load up extra content and remove the old one, so I had to find some sophisticated ways to trick it with jQuery. And this way I ended up with two playlists. The one I got from Last.fm, another one which is structured, another one was just a text file. And the task was to find and replace duplicate between these two playlist lists. Oh, I'm sorry, there is a little typo. I had to seek and destroy duplicates, since we are using theme. Now the problem, some titles were misspelled, they had different formats, sometimes the artist would come first, sometimes the song name, and the one list is just completely unstructured. And here are a couple of examples. The first line is comes from Last.fm TSV file. The arrow denotes a horizontal tab, just to visualize it. So the first field would be song name, then an artist, and then a canonical URL to that composition. The next one comes from my txt unstructured file. Here they pretty much match, as you can see. This is a good example. This is what I was striving for. But then I had examples like artist and a song name would be swapped, or the artist name used stylized Z for the same Cyrillic letter Z. Just, using the Latin to stylize the artist name. Sometimes they would be in a different case, even with misspellings, like it's supposed to be O with a stroke, and the O with a umlaut was used. Another example was missing a minor word in the song name, which was like not an integral part of the song name, but still can be considered official. Now, when I thought how to tackle this problem, I could think of two high-level approaches. One would be to go semantic. And by semantic, I mean having some data at hand, try to find the canonical representation of the entity. So like, given a song, everyone can understand that it's the same song despite how you refer to it. Maybe by its localized name, by its actual name, or like with that minor word in the title. But then you need to upload all your playlists to some service or have some source of authority, like Last.fm, or what is another one? Brains Music, if I'm not mistaken. Music Breaks, thanks. And then get the proper spelling out of that system. That was too sophisticated, so I decided to go another path, presentation. By presentation, I mean when you basically work with data given at hand. Like in my case, it's text files, so it's just characters, no matter what they represent. There was a definition of a problem. Now, one of the ways to do this presentation matching is using fuzzy text matching algorithms or techniques. And to explain what it is, you can try to do it yourself in your brain. And just read it. It doesn't matter in what order the letters in the word are. The only important thing is that the first and the last letter be in the right place in such a way. So you can realize that letters are shuffled within the word, but you still can get the meaning out of this paragraph of text. So you are subconsciously doing the fuzzy pattern matching in your brain right now. And this is what you want computers to do, to match the playlists. This is an example of application of fuzzy text matching. So one example is this, did you mean functionality can be found on Google, Wikipedia, and dozens of other websites. Another example is spell checking. I take your time, David.
That's fine.
Does it this. And a couple of other examples where the technologies may be applied, like to detect when somebody stole your text, your poem, your book, whatever, and shuffle some paragraph around or words to look it different and not match one-to-one. That's called plagiarism detection. It's also used in bioinformatics when these parts of DNA are represented in the form of letters. Then these strings containing letters can be also compared and matched against each other. Audio and image pattern recognition is, you've probably heard of this site, TinEye, where you can upload an image and they would do a reverse image search, find images very similar to the one that you upload. To some extent, fuzzy text matching is similar to these things. Record linkage is the area where you have same entities, like for instance books, but in different forms, for instance even with different titles, because they might be translated into other languages, but again representing the same entity. And you need to link them together to find what are representing the same book. And duplicate detection is very similar to the problem that we are considering now. So in other words, fuzzy text matching is when you are given a pattern and then a text, and you need to find that pattern in the text when the pattern doesn't necessarily match the text letter by letter, so to say. Edit distance is a very popular technique to do fuzzy text matching. I will discuss it first, but let's talk about this gentleman. Who can recognize him? That's a good guess, no.
Okay, Lewis Carroll.
Yes, this is Lewis Carroll. And he's most famous for his book Alice Adventures in Wonderland. But he was also a mathematician, a photographer, a logician. And there's this game that is credited to him called word ladder or doublet. Basically, you're given two words. You need to move from one word to another one, step by step, and at each step you can change a single letter in the word, replace it, but the word that is created must be genuine, so it should be a real word, not just some rubbish. And in this example, in these 5 steps, you can get from hand to foot. First to change H to B to bank, then A to O bond, and pond, food, and food. And this is a very, this is the idea that is behind edit distance algorithms. That operation is called substitution, when you change a character to another one. Edit distance also employs 2 other operations. Insertion and deletion, when you add a character, insert it either in the beginning or in the middle of the word, or the same way drop a character. And transposition, when you swap to subsequent characters, which is also very popular in misspellings, when your fingers are faster than your brain. This is an example of applying those different operations, like how to get from horse to roses. You first drop H, in this case, words don't have to be genuine, of course. Then you do a transpose operation, swapping O and R, and then you add a letter S to them. That's simple. And the edit distance takes on input 2 words, the one you are moving from and another you're moving to, and its output is a number. It's a distance between 2 words in terms of these primitive operations. And each operation has its own cost. So, say insertion would words 1, and substitution too, and this way algorithm can find the shortest path from one word to another applying with different operations. Levenshtein's distance, one we heard from Carl, is actually a concrete implementation of any distance, like among all these different ones. I frankly don't know where specifics of them, but they're mostly different in terms of what operations are allowed. For instance, in original Levenshtein instance, there is no transposition operation. You can only add, remove, and change letters. And in coast, each operation that is assigned to each operation, and they have their own areas of application. The longest common subsequence metric. I'm sure everyone on a daily basis faced with this algorithm when you do operations like git diff. So this one lies in the heart of the diff program that generates patches between two different versions of the file. Another technology, or technique, sorry, Kazan similarity. Before we get into details, because it's really hairy, anagrams. Everyone is familiar with anagrams, I suppose. A quick reminder. Anagram is a wordplay. When given a word, you need to rearrange letters within it and make another sensible word or a phrase. Like in this case, given a conversation, you can make a phrase to voice as random just by swapping letters around. And each letter should be used only once. You cannot drop a letter, you cannot use the same letter twice or more. If we split a word conversation into letters and keep count of each letter, we get this data structure. And we call it a vector. And the vector has a bunch of features. Each letter is a feature. Feature is a measurable property. Really, twice. It's really taking my time. Okay, thanks. So in this case, each individual letter would be a feature, and a number would be its value. And I'm sorry. This also, the cosine similarity can be applied with vectors, and vectors should be composed out of so-called Anagrams. This is another example when we take another word, the same principle, but instead of slicing it letter by letter, we slice it using a window that has a width of 2 letters. So each 2 subsequent letters forms a feature. And in this example, you can see this individual syllables. Each one occurs once, and the po occurs twice. These are called digrams, for D for 2 letters. This example is called unigrams. Yeah, thanks. When one letter forms one syllable. And now, having this, for instance, these digrams, imagine these are 2 vectors, having these features, and 2 words, one is misspelled, plotted in a system of coordinates, and the cosine distance would be like a relation between these 2 vectors. What it means in practice, there are formulas behind this, but giving some sophisticated input, you split it down into very simple features that can be compared and apply the cosine distance to it. This is an actual example of of applying cosine distance to 2 words, listen and silent. They are also anagrams. So we, for each string, create a hash of anagrams here. Anagrams count. We give a string, and this is the size of that window that we want to slice a string into. And then we add it to the cosine similarity object. The first argument is a label, just like an object, a vector that we give it. And the second one is a hash representing all features in the account. And when you do the calculated cosine similarity between them two, you get one. Like in the cosine function, when you have two vectors lying on each other that match, cosine of this would be 1. And as they start diverging, that increases, that the number decreases. And at the right angle, the square angle, you get 0. This is a rough idea of what is going on. Another algorithm is beta, which is very similar to, it works in terms of the edit distance, but opposite to it, it is so-called online algorithm. For the edit distance, you need to preprocess the text. This one can work on the fly. It only needs to pre-calculate the pattern. And this is an example of an agrep utility, Unix utility, that employs this method, this algorithm. So given a word and the cost, the maximal cost, ran against the Unix standard dictionary, you get two words, and you can see that one match 1-to-1, another one has one letter difference. That is exactly the cost of one substitution operation. This module implements another regex engine in Perl, TRE, which also employs the same algorithm. So giving again a max cost and runs against a string like a Perl is a hard object produced, matched against Perl, it matches and returns Perl, despite the original one has an extra letter. So that is a cost of removing one letter. Another class of algorithms are phonetic algorithms, which might be applied in some places too. They, given a string, they mostly work with proper names. It produces something that looks like a hash code. And that is supposed to denote, create strings for, create these codes for strings that may be spelled different but sound very alike. Regardless of how you try to misspell my name, you always get M250. Except when that's very different and sounds different. This algorithm is very old and is often can be found as a built-in function in databases when you need to match for first and last time and you don't know how it is actually spelled. This one in particular is developed to be used for English. Shall I do like this? Maybe let's extend it.
I think
Okay, 30 minutes.
that's okay, my talk is shorter.
It's
actually,
it's interesting. Let him go on.
Yes.
And he's just about to do the live demo, so it's
It's near done. One thing to make how it works. It takes the first letter. It's always given as is. And then it drops vowels and replaces consonants with some numbers. So like one set of consonants will be replaced with digit 1, another one is digit 2, and so on. And then it's also a fixed length, so no matter how long the string would be, it will just disregard all these letters. At least this, in this particular example, this is soundings. And there are many others with improvements for tailored to specific languages. Spoken languages. Now, actually, to the script that I made, that one employs the text fuzzy Perl module that does 11 time distance under the cover. So here we are given two playlists. This one comes from Last.fm, that is structured, it's a TSV file, track, artist, and URL. And another one is that TXT file that is completely masked. And this is the script. I will skip these parts first and we'll come back to them. First trivia, we open a file and populate a hash. And this is what I call authority, the Last.fm file, which is structured. So out of the information that I read, I make a string, artist-track, and then make a key out of it. I'll get back to what key is in a bit. Then I apply the same thing to another file, and this way end up with these two hashes. The authority hash and the candidate. And they have these keys that they generate, and they link to the song as they found verbatimly in the file. And what the key is defined by one of these two functions. It removes all, it splits, this one tries to take, given a string, like remember in Anagrams, we split into characters as features. Here we try to split into words. So the smallest token is a word. So we split by white spaces first, the given string. Then remove all non-letter and non-number characters out of it. Remove empty strings. Lowercase it and join it back again. You will see that in action, so don't try to run the Perl code in your brain. That's dangerous. Now, I go through the list of all candidates that I want to try to find in the authority file. I create a text fuzzy object and give it I give it a candidate key here. This is the string I am coming from, and then call the distant method and give it each song from the authority list. So that's actually n times m operation. I have m records from my candidates list and m records from my authority. Quite time consuming. And then I store the results, sort them, open a file optionally where I store results of comparing, and this is just an interactive loop, kind of like Git add interactive, to give a result and ask what to do, if that is a duplicate or not. But the program itself cannot tell if the songs are actually the same, but it gives me an option to figure that out. So when run, let's see. It looks like this. So the string involved is a song from my candidate list, something that I'm trying to find in the Last.fm file. And this in brackets is the key that I computed with that one-line function. So you can see that I dropped all non-alphanumeric characters in this instance. This was a dash, and sorted them. And then I did the same to all records in my authority file and compared them using the Levenstein distance. And these two records, you can see 0, distance between this one and this one, actually between the keys, are 0. And these are original records that match. So if I try to find the same record, I would fail. But giving this normalized keys, I found that they match. And these are just two other candidates, only top 3 sorted by the minimum distance. And so the list goes on. That's find an example where it differs from 0. Here, for example. Kim and Jesse, data remix, M83. And this is another record from another file. And you can see that they differed by a word, and it was present in this record, but not in this record. So, looking at these two candidates, I figured that, okay, this is actually the same song, and so forth. And when we get to the end, because as the list goes, the distance grows as well, and you can see that this is really, some are completely different, but they probably are different things. You need to apply 30 for different operations to make this to include this one. And another key generation function that I used was this one. It did the same, but did that on a letter basis, so kind of building Unigrams. And it looks like this. So it sorts all the letters to simplify, to facilitate calculating the edit distance. And that actually helped to catch some other cases that were not caught by the previous function. Does that make sense? Should I elaborate? But this is again the keys, consisting all of the letters that are found in this string. And just for the sake of the demonstration, this is an interactive mode. This is how I actually ended up having a deduplicated file. So for each candidate, it would ask me if this song is a duplicate, and these are the 3 best matches that are found in an authoritative file. And I reply yes or no, or as alternative all or none that just skips all the rest of the file or keeps the rest of the file. And you say no, this is no, this is no, this is no, this is yes, and so forth. And end up having a file with unique songs that doesn't exist. And just since we are on a music note, I would like to try to answer one of the ultimate questions, the Beatles or the Rolling Stones? And the answer is 11. That's it. Thank you.